Hi, welcome to the Commercial Gas Engineer channel. This pump is knackered. It was making a racket. It's a Wheelo Jonas Maxo 65. I checked some amps going to two other pumps to see what the ampage was on them when they were on the same setting. And I got 2.29 amps on one of the pumps that wasn't making a racket, working fine, getting the heat away from the boiler. Checked another one and it was 1.96 amps. And then the one creating the racket was 0.97. Funny enough, it was less than the pumps that weren't causing a problem and getting the heat away. So it wasn't drawing as much amps. In the BMS panel, I was trying to see which relays were lighting up when I turn on the selector switch, when the call for heat for the boiler came on. So when the switch live sent 8 volts DC over to the PCB. I think one of the other indicators were just one of the relays was like the lamp indicator coming on. So here I am checking the switch live to one of the boilers because I was getting a funny incident where it looked like the BMS was holding off the call to the boilers. Like there was a timer for the boilers to go off during the night. So I wanted to just see, because the boilers had to be put in controller stop, almost like forced on to operate. They weren't working on their own accord. So I wanted to know why. So I was just making sure there was a switch live to these particular Potterton commercial boilers. So this is where I checked on this Potterton commercial boiler on H1. I was getting about 8 volts DC. Here's another boiler where the switch live wasn't receiving any power from the boiler. And you can see there's no current. And as you can see here, here's the timing for the boilers to switch off in the night before they were adjusted on the BMS. So I think it was set up for the boilers to just switch off in the middle of the night and then come on again at 5 a.m. in the morning, but that wasn't adequate for the winter period. And this is the same boiler with a call for heat on it. And this is a particular issue that I had on the BMS control panel. I was checking PRVs because there was a leak when I walked into this particular plant room. So I was trying to trace where it was coming from, hoovered up a lot of the water with a wet vac, but still couldn't trace where the leak was coming from. And the pressure hadn't dropped significantly. One of the boilers where you heard that noisy pump, the velo pump, wasn't getting the heat away quick enough and was making a humming noise and was pulling below 1 amp. The boiler was coming up with a fault indicator and the heat wasn't getting away quick enough from the boiler, so that pump's going to need changing. And the boiler was going up, even though the set point was being set to about 75 or 80 Celsius, the boiler was going up to 95 to 100 in some cases. It wasn't kettling, but it was actually starting to overheat. And this is a little rigged up quick fill put in place, as for some reason there was none plumbed in when the building was designed. There's a pressurization unit, but that also has a fault. So this was just a quick fill setup. And then 1.3 bar on this side of the plate. So there was a plate to plate heat exchanger, and then one side we had 1.3 bar. Or when we found it, it was about 0.8 bar, 0.7, 0.8 bar, but that was adequate. And then the other side, I think it was about 7 bar of pressure on the other side of the plate heat exchanger with the other pressurization unit. So just went into the bottom of the dosing pot in order to top that system up. So here is when I had the system sort of like in controller stop, in service mode to force the boilers on initially. And here you can see on the BMS control panel the rise in temperature when I got the boilers going. And here's the pressure, which the system was almost found out. I think it went up slightly once the boilers came on. And when I arrived to this site when the leak had appeared, the BMS control panel, I like to take pictures of BMS control panels almost as though like you arrive on a crime scene and an accident's taking place. You want to gather all the evidence before tampering with it. So I take pictures of the BMS control panel instantly and try and gather any information, any alarms on the BMS panel, any alarms on the boilers, and write things down. So I tried to do that, tried to take pictures. So I had boiler 4 in fault and boiler 2 in fault on arrival. This was the temperatures I found on the site when the leak had occurred. You got the boiler's flow was at 30 Celsius. So that was obviously a problem straight away. And it wasn't much water on the floor in the plant room. This was very limited amount. It was hard to trace the leak though. I didn't actually find where the leak came from. Assumed it was from a PRV, but still not 100% where this leak came from. Whether it could have been rainwater or something else. But because the pressurization unit had decent pressure in it despite the leak, because when left before it wasn't that much different. But the pressurization unit pump had failed in the past, and it says that the pump is running, but the pump has power going to it on the pressurization unit, but it isn't actually running. A unit was not working. The one on the far left, should I say, the one on the far left was isolated, and there were two units down here. One was working all the time, this particular unit here, but the one in the middle kept locking out every so often. So what was done, the ignition board on the left was changed over, the aqua board was also changed over, and the burners were taken out of the decommissioned unit, cleaned up, put over, combustion tested and so on, burner adjusted and so on, gas valve adjusted accordingly, and made sure it was safe, fags carried out, and then the unit stopped cutting out. So it looked as though it was down to the burners or possibly the ignition board. Okay, in this particular site, I was carrying out servicing on the boiler. I'm going to go in backwards mode here. So this was me after carrying out the servicing. So I was getting my logs for my readings, my high and low fire. So I'm printing out my high and low fire readings. I log it on my analyzer, because sometimes on some of these, by the time you hit print, the readings that come out aren't the readings that you're expecting. The boiler could have shut off in the meantime. So I like to log first and then print out later. Let me know what you do. So I was here trying to compare my printouts after servicing, after cleaning down the burner, and the previous service that was carried out. So for servicing purposes, I had turned the boiler up. I turn it up to like 90 Celsius during servicing so that it doesn't lock out too quickly. So I was putting it into low fire because I had already put it into high fire. But I was well, actually what I was doing is I was putting this boiler back into hand and replacing the test point after carrying out servicing. But I was putting the unit into hand because for some reason the boiler wasn't receiving switch live power. I believe it wasn't really receiving a signal from the BMS to come on. I think it's because there was a problem with the pressurization unit. So I believe it was holding off this boiler from coming on. Whereas I think another boiler that was coming on had been possibly linked out from the BMS and was running directly. So you can see here, this unit here has fired up. This was after servicing. So this here is the boiler fired up. It's in hand, and I left it at 75 Celsius. Or should I say I left it at 80 Celsius. Stage 5, status 5. Okay, so I'm putting it into low fire here. It's hard to remember how to get these in low and high all the time when you work on them different boilers. So this is in high fire. I'm waiting for my analyzer to purge. I'm waiting for the unit to come on. Here the unit is, it's come on. I'd clean down the unit, you'll see that in a moment. And just waiting for my CO2 to go up. And the CO2 is going up to 1. This is low fire, yeah. Wait for the unit to start up. So the unit started up, and then I'm just checking my CO2. Low fire. So this is the burner out. Just giving it a clean down with some boiling water. So when putting the burner back in, I was just making sure that the fan was back in situ and the connections, and then I re-established my gas supply and turned my boiler back on. and I kept an eye on my flow and return temperatures. Then switch my unit back on. Here's how where I decided to take the burner out from. There are different various places that you can, or how you can go about removing the burner. We all have our preferred methods. It does help to have certain socket sets that can get into awkward places, and to have a full service kit with all the appropriate gaskets. Good to have the right brushes to get into the different angles. Before the burner came out. Look inside before I washed it. And then here's a little look inside. Condition doesn't look too bad. Always remember to isolate before you carry out any work. It's good to have at least 2 points of isolation if possible, and check for safe isolation as well. And use your try and use gloves all the time, and VD rated tools, and make sure you got your rubber sole boots on. Okay, just getting the probes out to check the gap and the condition of them. Doesn't look too bad. Okay, here I'm carrying out some servicing on a forced draft burner, making some adjustments in high and low file. So I'd established on one of the forced draft burners I was working on that the gas valve was faulty. I came to find that because when I was making adjustments on my high fire, nothing was taking place. I wasn't getting any increase in my pressure, my combustion head pressure. So I was making adjustments on my gas, and yeah, no matter how much I was turning, there was no difference. You can see where the gauge is, where the pressure is there, and then over here on the high fire you can see where the pressure is, and it was moving up and down, but I'm still getting no difference in the readings on my manometer. As you can see here, 16.2. So this was a unit that was working. So I had 16.2. And then when I made some slight adjustments, you see I've gone from here at about, say, 5 o'clock to over here at about 7, 8 o'clock. I went from 16.2 to 15.7, and then I made it back up to where I started out. Whereas when I worked on another unit, it was not working. So the gas valve was gone on this particular unit. The unit was locking out on lack of air. So that during operation there was a lack of air. So what I had to do is increase the amount of air it had, but I couldn't increase the amount of gas. So I just increased to the servo motor in order to make adjustments to increase air to the combustion in low and high fire. But the gas valve is going to need changing. But the unit stopped locking out because it started to get adequate air for combustion. Let's have a look at the unit in operation. So waiting for sequence control box to go through the firing sequence. So this was before I had made adjustments to the servo motor, so the unit was locking out on low air. So as it gets to the end of the green stage, the unit will fire up, but when it got to the end of the green stage on this sequence control box, you'll see that it locks out. So you can see it's firing, but during the ignition process, you can see the flame strength there. So look at the flame, then the unit locks out in the green. Let's move in the Allen key. A lot of time these lockout, as I'm sure you know, is that the probes need cleaning, because a lot of these units pull in a lot of dirt and dust from plant rooms, and these are lighting up all the time, so they just need to be cleaned. Here's a look inside the unit. It looks like there was a bit of debris inside there. And just giving it a brush through. Okay, and had another unit where the unit had gone off, and then you can see what happens when the gas engineer shows up on site and the boilers come back on. There you have it. So I had two boilers here. One of them light locking out, so we had to look at that bad boy. And here it is here. The sequence igniter gives you an indication. So here it is, it's firing, and then it decided to lock out. So I took the burner out and then had a look at it to see the positioning. Looked okay, so gave it a clean, but this was filthy. I think this was the most filthiest one I had seen. I think it was an RS something, another, it was a Riello, but this was one of the dirtiest ones I'd come across. It was in a bad state, like it had never been cleaned. So yeah, I think this was disgusting. It was just too dusty. And this is another site where I'm just checking the head pressure on a dab pump. It was just increasing the head pressure from 6 meters to 7. As you can see here, the reason why I was increasing is because the heat wasn't really getting away from the header, the header area on the boiler, and not getting away on the variable temperature. And the pumps were sometimes at like 1-2 meters of head, but it needed to be more like 6-7. So I made an adjustment and changed that. So the heating flow started to increase significantly, and the boiler's return began to drop. As you can see here, there was a discrepancy, but that changed. Also, the hot surface flow temperature wasn't actually 45. The sensor was 40. It was a lot hotter and you could barely touch it. So this is a leak on a roof. Hard to find. Sometimes when you see a system constantly filling up and losing pressure, you wonder what's happening, but this was happening because there was a leak on the roof. Okay, and last but not least, I was asked to check one of these digital TRVs. I haven't come across many digital TRVs, but you probably have. So here I just tweaked it up. They didn't know how to turn it up, so I did that. I got a recording of the temperature initially, and then I got a picture of the temperature rise once an adjustment was made. It's good to have evidence. Okay, time for me to go and play with some boilers. Until next time, thank you for joining me. Please leave comments in the section below. Bye.